All right, so welcome back to OneClass. Again, my name is Joey. I'm going to be your math teacher for this session. So if you're here for the first time, thank you so much for watching. What we're doing here at OneClass is we're providing online resources and videos basically for all students and all learners. And what we're doing is we are here at OneClass. What we're doing in this session is we're verifying solutions to frequently asked questions in secondary level and university and college level mathematics and in chemistry. So my job here today is I'm going to verify some solutions for you. I have about 10 questions that range from basically grade 10 math all the way to grade 12 calculus. So we're going to go over the questions. I'm going to teach you the concepts behind those questions, and we're going to break the solution down from by parts to hopefully get through to you guys about what the thinking behind the question is and what the rationale in answering the question is. So, my name is Joey. I'm currently a secondary school educator in Ontario. My specialized subjects and my teachable subjects are indeed chemistry and math. So I'll be able to help you out through this journey of answering questions. So, without further ado, let's get started on today's problems. I have 10, or I think I have 11 of them through in this kind of a collection of questions here. So let's look at number 1 here. I'll give you some time to think about this question as well. So it says here, the sequence is defined by the formula f of n plus 1 equals f of n minus 3. If f of 4 is 22, what is f of 1? So let's look at the question here. It's asking us, we have f of n plus 1 equals f of n minus 3. That's asking us if f of 4 is 22, what is f of 1? So I'll give you a moment to think about this problem here. This here is we're in this concept of arithmetic and geometric sequences in series, right? So you can think of it as sequences. This is specifically a sequence, so a sequence, and then you can think of it as arithmetic or geometric. In this case, it would be arithmetic sequence specifically, but we're in this idea of sequences in series, where the one term would affect the next term, and so on and so forth. So we have a sequence here, and this is kind of our sequence. Our arithmetic sequence here, we're given f of 4 is equal to 22. We have to find what is f of 1. So I'll give you a moment to think about this question, and then we will reconvene and answer and look at the question as well. If you're stuck, you can always see what the sample solution as well to see how you would get this problem here. So, or how do you answer this problem here? So give you a moment to think about this problem, and then we will answer it in quickly as well. So let's think about this problem. Let's break it down into a couple parts here. So we have f of 4 equals 22, and we can actually sub f of 4 in for f plus 1, right? So if we know that f of 4 is 22, we can say that here this is simply just f of 4 here is simply just 3 plus 1, right? So we know that n here would equal 3 in this case. So I'm saying here if n equals 3, therefore, and we're given f of 3 plus 1, which is 4, equals f of 3 minus 3, right? 3 minus 3, right? We know f of 4 here equals f of 3 minus 3. We know f of 4 here is 22, right? As given in our sample here. So it says 22 is f of 3 minus 3 here. So we're going to work backwards, and we're going to figure out what f of 3 is from f of 4. So f of 3 here is simply, or 22 here is equal to f of 3 minus 3, right? And we can move 3 to the other side to add 3 to both sides. We get f of 3 here would equal 25, right? So we have 25 for f of 3, which is good. And now what we can do is we can solve for if n equals 2, right? Because if I have here n equals 2, then we have f of 2, or let me do some black, sorry. We have f of 2 plus 1, which is 3, and we know that. So f of 2 plus 1 equals f of 2 minus 3, right? And we know that f of 2 plus 1 equals f of 3 equals f of 2 minus 3. And we know that f of 3 here is 25 and equals f of 2 minus 3. Add 3 to both sides, so therefore f of 2 would equal 28, right? F of 2 here would be 28. So we see some sort of pattern here, right? Or hopefully you see some sort of pattern here. We have f of 3 is 25 here. Sorry, f of 3 here is 25. F of 2 is 28 here. And we started with f of 4 here equals 22, right? F of 4 here is 22. So we're trying to find what f of 1 is, right? So as you can see, 22, 25, and 28. As you see, my numbers are increasing by 3, right? As denoted by f n minus 3 here. This negative 3 is simply because we're going backwards, we're adding 3 to these numbers here. We're going forward to 1 and not 1 to 4 here. So from 4, 3, 2, and then 1, we are adding 3 to both sides. So therefore, if I were to solve for f of 1, so therefore, box mode still. Therefore, if I'm still at f of 1 here, if I'm adding 3 to both sides to every time I drop the number by, I drop n by 1, obviously f of 1 would equal 31, right? And I can prove that. I can prove that by saying if here n equals 1 here, then I have here f of 1 plus 1 is f of 1 minus 3, right? If n here equals 1. And I know f of 2 is 28, right? This is f of 2 equals f of 1 minus 3. I know f of 2 here is 28, right? 28 would equal f of 1 minus 3. I can then add 3 to both sides. Again, I would get f of 1 here would equal 31 here. And this here is my answer for this problem. F of 1 here is 31. And as you can see, they also got the same number. F of 1 equals 31. They basically did the exact same thing, but they wrote it in... They wrote it so that they're substituting again. They're solving for n here equals 1 through n, kind of using this similar concept. So they assumed here n equals 3, and then n equals 2, and then n equals 1, and they finally found what f equals 1 here is in this case. So in this case, the solution is correct. Solution is correct. Good analysis here. Okay, that's number 1. Number 2 is asking, B is the product of two irrational numbers, or is the product of two irrational numbers always an irrational number? Either prove that this is the case, or give an example of two irrational numbers, the product of which is a rational number. So it's asking us number 2. It's kind of a thinking question here. So is the product of two irrational numbers always an irrational number? So let's look at a few irrational numbers here. So first we have to ask ourselves, what is an irrational number? So you can think of a rational number as a number that kind of keeps going on, and there's no really definite end to the number as well. So common irrational numbers are, like say pi here is approximately 3.14, and then 1592, you can go on and on. So pi is an irrational number. Root 2 is also an irrational number. So root 2 here is about 1.41. But again, this can go very, very far as well. So it's approximately 1.41. Other common rational numbers, E, maybe you've heard of here, is 2.71. This here is an irrational number as well. And this, or 2.72 actually, sorry, not 2.71 if I were to round it. It goes on and on as well. So the question is asking, is the product of two irrational numbers always an irrational number? So if I multiply, for example, let's do case one here. So let's solve this using a logic. So case one, if I had, let's say, pi here times root 2. Both of these guys are irrational numbers. So if I were to multiply pi by root 2 here, I would simply just get root 2 times pi, right? I wouldn't get anything that's out of the ordinary. If I were to actually multiply these numbers and in terms of that, I would get some sort of value, right? In this case, this would be, case one says that if I multiply pi by root 2 here, this would also be a rational number. Therefore, irrational product here, right? So in this case, both of these guys here, both irrational numbers, but the product of both irrational numbers here will always be a rational number for this one. So that's case one here. So we prove this, so this could be true. But let's use another case. Let's do maybe let's do 3 cases here. So let's do e times root 2 here. So what's e times root 2? E times root 2 will also be a rational number, right? 2 times e here, simply just root 2e, right? So we don't really have, this here is not, this here is also an irrational number. So therefore, it's also a rational number, or rational product. However, let's look at my last case here. My last case would be, what if I multiplied root 2 by root 2? If I multiplied root 2 times root 2 here. Both of these guys individually are rational numbers, but the moment I put them together here, root 2 times root 2 is obviously root 4, right? And root 4 here, we know equals 2. So this here is not an irrational number here. This here is a rational number, right? So therefore, this statement has been disproved by this case here. If I simply just multiply basically any two radicals or any two of the same radicals together, it will give me a rational number. So in this case here, this statement is not correct, right? So is the product of two rational numbers always a rational number? The answer here is no. And we prove this using case 3 here, because root 2 times root 2, both are rational numbers, but when put together, they give me a rational number. So in this case, I'm going to say solution is correct. However, it's vague because they didn't really give me an example here. So because there is no explanation, and then we'll write our explanation here. So let's do so square root of 2 multiplied by square root of 2 equals square root of 4, which equals 2. Product of two irrational numbers gives me a rational number in this case. So obviously solution here is correct, but it's just very, very vague as how they would answer this question here. So that's number 2. Number 3 is asking, what is range in math? So this is a very vague question here, but it's asking, what is range in math? And here, I'm going to read off the solution for you, just to kind of anchor ourselves in something here. So it says here, in mathematics, the range particularly comes under functions, which is correct, where the function is showing the relation between the sets. To know about the range, first we need to know the domain and codomain of functions. In simple terms, the domain is showing the input values, the codomain is showing the possible output values, and the range is showing the actual output values. So the range in mathematics shows the actual output values, which come from the domain of the function. So this here is true, but it's kind of wordy. So let me just draw a function for you. Let me look at this function here, and I'm going to take this function here. So I'm going to assume here this is y equals x squared, and I have here it's not perfectly at 0, 0, but it's okay. I'm gonna assume that this is the vertex here is 0, 0. But so what is range in math? When we're talking about range in math here, we're talking basically about the output values, right? So we're talking about where does my function exist in terms of the y value. So function exists in the, I'll say y domain, or no, I won't use the word domain, or in the y axis here. or where does my function exist, right? As you can see here, I'll do some blue. My function exists only in terms of the y, only in terms when it's above 0 here, right? Because I have all my function, my function exists here and here as well. But as you can see, my function does not exist in this in this region as well, right? The vertex of my parabola here is already 0, 0. So therefore, my function does not exist when it's below 0. So therefore, if I were to write my range of this function, if I were to write the range of my function, I can say that here y, or I can say the range here for r semicolon is, and I use kind of these squiggly brackets here. I can say it's y is a set, belongs to a set of real numbers. And I can also say that y here has to be greater or equal to 0, right? Y has to be greater or equal to 0 because my function, my y here, can exist at 0. The vertex of my parabola here is 0, 0, right? So it does exist. It has a defined value at 0, but it only has defined values as if it was greater than 0. I wouldn't have I can't. My function does not exist below 0 in terms of the y-axis. And as you can see, you can prove that with algebra, right? I can't every time I square a number, it will not give me a negative number, right? Again, if I square a positive number, it gives me a positive number. If I squared a negative number, it will give me a negative number or a positive number as well. So therefore, my function, that's kind of the definition of range in math. So this here's the solution is correct. I wish I kind of had a function to kind of graphically show you kind of what is range in math, but this comes back to the topic of domain and range and what exists in terms of the function in itself. So I'm going to say here solution is correct. Let's say good analysis here. It was a little bit wordy, but it's okay. We'll give it to them. It's more so just talking about the function that existing in terms of the y-axis and how we can actually use interval notation to write down specific values in which the function lies on in terms of the range of the function here. Obviously, this is the y-axis. If you want to talk about the x-axis here, it would be the domain. So in terms of this domain here, the domain of this function is x is all real numbers, right? If I go in terms of the positive infinity on the right hand side here and negative infinity on this side here, my function will always exist, right? Even if I put negative 100 squared here, I'm going to get a negative 100 squared, right? I will get a y value here. So if I were to talk about my domain here, in terms of my domain, there's no restrictions in my domain, right? X belongs to a set of real numbers here, and there's no restrictions on that. So I'm going to say solution here is correct. Great analysis for this question. So good solution here is correct. Look at number 4 here. So number 4 is writing here. It says solve the inequality algebraically. I'm going to write this down, and you could take a few moments to figure out this problem here. So it says solve this inequality algebraically. So I'm going to write this down here. So 2 times 4 plus 2x is greater or equal to 5x plus 5 here. So I'll give you a moment to think about this problem here, and then we'll take it up in just a hot sec. So again, when we're talking about inequalities here, we understand this concept of inequalities as kind of like equations, but how we would solve. But the only exception is every time we divide by a negative number in the inequality, it flips the sign, right? So let's treat this as an equation first. And then we basically treat this greater or equal to whatever inequality here as an equality unless we divide by negative numbers. So we do the exact same steps here. So we open up the bracket, we use distributive property here. So it's going to have 2 times 4 here and 2 times 2x, right? 2 times 4 gives me 8. 2 times 2x here gives me 4x here. So it's less or greater or equal to 5x plus 5. We can do the exact same thing, and we can what we can do is we can bring the x's to one side here. So 4x, I'm going to bring 5x to the side here. So I'm going to subtract both sides by 5x, which will give me negative x here. Or I have 8 minus x is less than 5 here. And then I can bring obviously 8 to the other side, and I would subtract 8 from both sides, and I would get negative x is greater or equal to negative 3 here. Oh, why does that always happen? Oh, I don't want to do that. 3? Sorry, give me a second. 3. Can I write, please? Oh. Why is it? I don't want to zoom. Why is it zooming in? Sorry, just give me a second, guys. Okay, I don't think I want to zoom here. Oh, there we go. Here, this should equal negative 3. 5 minus 8 here is negative 3. And again, the moment we divide both sides by the negative here, we're dividing by a negative number. In this case, we're dividing by negative 1, right? So in this step here, in order for me to get rid of the negative number, we're dividing basically both sides by negative 1. And the moment we do that, we have to actually flip our inequality, right? So if by dividing by negative 1 here, I'm going to get x here. Instead of greater or equal to, it's going to be less than or equal to positive 3 here. And this here is my answer for this inequality here. X is less than or equal to 3 here. And because when we divide both sides by a negative number here, this will flip our inequality. So this here is our correct answer. X is less than or equal to 3. And this here is the correct solution because they wrote the exact same thing, but they just flipped the order here. So solution here is correct. Good analysis here. So number 5 is asking, let's look at question 5. Yes, this is 5 here. It's asking us if f of x is 3x minus 1 and f of negative 1x are inverse functions of each other, what is f of negative 1, or the inverse function of 8? So it's saying here, or what is f of negative 1 at 8? So here's number 5. Asking if f of x equals 3x minus 1, and we have f of negative 1 of x here. This is the inverse function. You can think of this as an inverse function. F of negative 1 just means that it's the inverse function of f of x here. And it's asking us, what is f of negative 1 evaluated at 8, right? It's asking us, what is this value here? Let me write this nicer here. Sorry, this is 8 here. Equals what value here? So first, what we have to do is we have to find what the inverse function is, right? We have f of x here equals 3x minus 1, or you can rewrite here. You can rewrite f of x as y here equals 3x minus 1, right? So the moment we write y here equals 3x minus 1, what we're going to, in order for us to inverse the function, what we're going to have to do is just switch x and y, right? So switching x and y will give me the inverse, right? Will give me inverse. So let's do that. If I flip it, I would get x on this side here and be 3y minus 1, right? So this here would be, if I flipped both my variables together, and this here would be the inverse function of my of f of negative 1, and all I'm gonna have to do is rearrange for y, right? I'm gonna algebraically rearrange for y here. So if I want to move, I want to basically isolate this y value here, so I'm gonna move negative 1 to the other side, so I'm gonna add 1 to both sides. I'll have x plus 1 here equals 3y, and then what I could do is I could divide everything by 3 in order for me to get y by itself, right? So I'm gonna have y here equals x plus 1, and it's gonna divide it, it'll be, sorry, x plus 1, and then it'll be divided by everything by 3 here. So this here is my inverse function, or you can say this here is, which equals f of negative 1 of x, right? Of x here. And what we want to know is, what is f of negative 1 at 8, right? So if I know that this here is my inverse function, so if I can rewrite this as f of negative 1 of x equals x plus 1 over 3. And what I can do is I can plug in my 8 value here, right? F of negative 1 at 8, which simply equals 8 plus 1 over 3, which is simply just 9 over 3. 8 plus 1 here is 9, which 9 divided by 3 here is simply 3. So I can say that f of negative 1 at 8 equals 3. And this here is my final answer for this question. And as you can see, f of negative 1, they did the exact same thing. 9 over 3 equals 3 is the required answer here. So the solution here is correct. And what they did is they actually did the exact same thing, right? They set y here equals 3x minus 1, and they flipped it to y here equals x plus 1 divided by 3 here. So the solution here is correct. Good analysis. So this was question 5. Sweet. Question 6 is asking us, what is the simple interest accrued on $7,500 at 6% of 90 days? I believe I've done sort of these questions as well. Simple interest problems before. What did I do? Simple interest on $7,500. Oh, what? I'm pressing about $7,500 at 6% of 90 days. So when we talk about the simple interest, what we have to do is, on a test, what you usually get is you actually get a formula sheet in terms of what the simple interest, future interest, like annuities, values. You get all of these formulas on a sheet, right? So in order for us to grab that, what we can do is we know that our formula for simple interest is simply, we can say it's A here. A here is our final amount. In this case, is our final amount is equal to P, which is our principal, or what we're going to start with. P here times, I have 1 plus RT, where R here is the interest rate, and T here is time, and this is in years. Here. So given this formula, what we can do is we can actually simply just use this formula to solve for our problem, right? So we have here, we don't know what our final amount is, so we're solving for our final amount, which is A. Our principal is what our starting value is. So our starting number, we put in $7,500 into the bank. So $7,500 into the bank. It's 1 plus, and the R here is interest rate. And the interest rate is, it's given in percent. So what we're going to have to do is convert it to decimals, right? So 6% here is obviously going to equal 0.06, right? 0.06, or you can think of it as 6 divided by 100. And then that's our R value, and we have to multiply it by our T value in years, right? And time is in years. In this case, we have 90 days. So in this case, we don't specifically have, it's not multiplied by 1, because 1 would be 1 year, right? So we have to actually write a decimal or fraction in terms of how do we figure out what 90 days of a year is. So I can simply just put 90 over 665, because we know that there are 365 days to a year. So this here would be our formula in this case here. So if 7,500 is our principal, 1 plus 0.06 is our interest rate, and then 90 divided by 365 is a fraction of what this year of what 90 days in a year would be. So we basically convert it into years here, and all we have to do is just plug this in our calculator, right? And then we will get our final answer. So this here would be 7,500 is 1 plus, and then let me just type this in my calculator. So I have 1 plus 0.06 multiplied by 90 divided by 365 here. 0.06 times, let's see, 90 over 365. This will give me a value of 0.01479. So I'm going to write this down, 0.01479. I'm going to add that by 1. It would give me a value of 1 plus that would be 1.01479, and then I just have to multiply that by 7,500 to get our answer, which would equal $7,610.96 here. So this here is our final amount here. on our principal, which was 7,500. So we amassed in total. Our final amount is $7,610.96. So but the question here is we're not done here. Right? We're not done the problem because it's asking us we only care about this simple interest, right? This here is our final amount. It's not our simple interest. So what we're going to have to do is we're going to have to take our interest here. It's going to equal basically our final amount minus our principal, right? We don't really care. The principal was $7,500. That was our money, right? We care about what bank or how much did the bank actually pay us on this simple interest here. So interest rate would equal A here, which is our final amount, which is basically the number calculated here. So $7,610.96. We're going to subtract that by the initial amount, our principal balance, which was $7,500, right? And we put in $7,500 in the beginning here. And this here would equal, our interest that's being accrued, right? Accrued. And this would give me a value of $110.96, right? So our interest rate here is $110.96, and this here is our answer for this problem here. Again, it's $110.96 is only interest, right? So as you can see, this here simple interest equals $110.95, very, very close to 96 cents here. So the solution here is correct. Their formula here is simple interest equals P times R times T over 100, I believe. And this here gives us the exact same answer as well. So you have, again, 7,500 is our principal number. The rate of interest is 6%, and time is, again, 90 divided by 365. That's good. And basically, they just plugged it into the equation as well, and they simplified. So this here solution here is correct. It's a good analysis as well. All right. Number 6. Number 7 is asking us how do you evaluate log of 100? How do you evaluate log of 100? So this here is number 7. So evaluate log of 100. So when we talk about logarithms in this case here, this is probably a grade 11, grade 12, or algebra 1 or basically an algebra 2 and pre-calculus question here. When we talk about log of 100 here, we need to know our logarithmic rules, right? So when we say our logarithmic rules here, it's saying, and they wrote this down perfectly, which is basically log of some base, log of base, basically the base of x of y, or sorry, give me a second. Oh, so finicky here. So log of base here. Oh. Log of bx equals y. And when we basically bring up what we can do is we can move log to the other side, right? The moment we move it to the other side, the b becomes our base here, and y here becomes our exponent, and this here becomes our x here as well. So let me just redraw this. I think this is kind of messy here. So this is log of base of x here equals y, and basically the moment we move log to the other side here, we get x here equals b of y, right? So basically this log here becomes the base of our exponent here. So that's the inverse of log, right? So you can think of logarithms as inverse of exponents. So in order for us to get that here, so we have, knowing this here, so if we have log of 100, we have log of 100 equals our y, right? We don't know what log of 100 is, but we know that log here is always base 10, right? So log here is base 10. If the base is not mentioned, we have to assume that this is log base 10 here. So knowing this logarithmic rule here, if log of b, and in this case b here is 10, x here is 100 equals y, then x here is simply just 100 here equals 10 to the power of y, right? To the power of y, right? And this here is, again, y here equals, or x here equals 100, sorry. B here is our base, which is 10, and y here equals, y here equals our exponent, right? And again, we know that, now we can solve this problem here. We have 100 equals 10 to the power of y. What number y would belong here to satisfy this equation? We could use, again, trial and error to figure this out. Or if you know that 10 squared equals 100, then we know that here y here equals 2, right? And this here would be our answer for this problem. Like if log of 100 would equal 2 here, because I know that 10 squared equals 100. So this here is one of the ways we can solve this problem. Or what you could do if you had a calculator, what we could do is you could actually just simply type in log at 100 and figure this out for yourself as well. But this solution here is correct, right? Y here equals 2. They did the exact same thing here. They did the exact same thing here as well. So this solution here is correct. So y here equals 2. So therefore, if we evaluate it, log of 100 equals 2. And you can check that on your calculator as well. So solution here is correct. Good analysis. Okay, so that's number 7. Number 8 is asking us if a polynomial function f of x has roots of 4 minus 3i and 5, what must be a factor of f of x? So let me take out 8. Yeah, this is 8 here. Yeah. So if a function has the roots, so let me list the roots here. So roots here are roots are 4 minus 3i, and 5. So it's asking what must be the factor of f of x. So it's asking is a factor of f of x here. So as you can see, we have 2 roots here. If we have 2 roots, we have 1 root here and 1 root here. This must be a quadratic function here, right? Because again, a quadratic function has a maximum of 2 roots here. So we could assume this is a quadratic function. However, we could have actually a higher order polynomial and with only 2 roots here. But for the sake of this problem here, I'm going to assume that this polynomial here is quadratic. So if it's quadratic here, and I know here I have 2 roots here, I can simply say that f of x here equals, I can say that it's going to be x minus 4 minus 3i. And then I have here, and 5 here, right? So again, I have here, x here would be minus 5, because again, this is a real root. 5 here is a real number, it's a real root. And 4 minus 3i here is actually an imaginary root, right? This is written in terms of in a complex number here. So in this case here, we have this is a complex root here. So if you know from complex numbers, in this case here, 4 minus 3i here, the conjugate or the complex conjugate of the root here is also a root as well. So we can say that 4 minus 3i is a root, but we have to also assume that 4 plus 3i here is also a root as well. And knowing that I here is the square root of -1, right? So this here is also root. So therefore, we can say that our real root is obviously 5, so x minus 5. We're going to multiply this by x minus 4 minus 3i, and obviously x minus 4 plus 3i here. So this here is our polynomial solution here, and this will not be our quadratic now. This will now be a cubic function because of the inclusion of the 3rd root here. Or it could be a cubic function, but we don't really know in this case here. So this is 4 plus 3i here. And this here is our, these are the factors of the polynomial x. And as you can see, hence x minus 5, x minus 4 minus 3i, and x minus 4 plus 3i here are factors of the polynomial. So these are all factors of the polynomial function. So this solution here is correct. Factors of polynomial function. The tricky part of this question here is simply just this complex root, right? We have this is a complex root here. And the moment we see a complex root, we have to also care about the conjugate root, right? So 4 minus 3i, the conjugate root is we just simply flip the sign here. 4 minus 3i becomes, and we have to also include 4 plus 3i here. So this solution here is correct. Solution correct. Good analysis here. And this is number 9 here. So that's guess a Norman window has the shape of a rectangle with a semicircle on top. See diagram. If the perimeter of the window is 30 feet, find the dimensions of the window with the greatest possible area. Round your answers to 1 decimal place. So this is actually this is part of a grade 12 calculus question here. This is the concept of optimization. So basically what we're going to have to do is we have to first draw a diagram. So let me draw a diagram first. So we have a shape of a rectangle with a semicircle on top. So it probably looks something like this here. And then we're given the perimeter here is equals 30 feet. And we want to find the dimensions of the window with the greatest possible area. So greatest possible area, we want to maximize this guy here. Maximize our area here. It says round your answers to 1 decimal place here. So as you can see with the solution here, the solution is not very good. Again, it just tells us what to do here. It doesn't actually give us a solution here. So let me just read this for you as well. So it says the area of the window can be computed as a sum of the area of the rectangular portion plus the area of the circular portion. So this here is correct, right? So when we're talking about the area of the Norman window here, do this in blue here. The area total here is basically equals the area of the rectangle, which is I can say here's the blue, this blue part here, is the area of a rectangle, which we know as its length times width, right, of our area, plus the sum of the semicircle, right? So I can say it's the area of our rectangle here and the area of our semicircle AS here. So total area is simply just length times width plus I have area of a semicircle. So if I know area of a circle is pi r squared, the area of a semicircle would have to be half of that, right? So it's going to be half pi r squared here. So this will be our area total here. So knowing this here, we have LW plus half of pi r squared here. In this case, this here is the radius of our circle, right? In this case, the radius of our circle, this here is the radius of our circle, but it also equals our length or the width of our rectangle here, right? So I can actually replace this r here with w, right? So this is going to be AT here equals length times width times half times pi w squared here. W squared here. And so what we have here is we have our area equation, which is perfect here. So this here is correct. So in other words, it says this is the first part here. So I've written this out mathematically, and they'd include that. That's okay. So it says, in other words, since and let us denote the area of the window. So we have, oh, these are not proper sentences. It's okay. I'm going to see if I can, now observe that the minimum value of the height and the maximum value that can take is when. So we have to maximize the function in the interval. We find the derivative and the critical points by solving something. Since the critical point lies within the interval, and to find the maximum area, we evaluate the critical point and the endpoints. This implies that the maximum area and attained when the radius is height is something. So clearly, this is a copy and paste of something that was actually like something else, but I don't think everything copy and pasted. So unfortunately, we don't get the answer for this problem. But what we can do is we can simply just solve it, right? So again, we have our area formula here, and what we're gonna have to do in order for us to maximize our area, we have to take the derivative of this function here. So we're gonna take the derivative in respect to with respect to our a here. So I'm gonna say here, we're gonna take the derivative of this. So I'm gonna say a total prime here, this will be the derivative here, equals, and I can take it in with respect to, in this case, probably in respect to width, because I can see I have w in terms of both, on both terms here, w in both terms here. So if I take the derivative of that, I would get L. The LW just simply becomes L, and then plus I'm going to bring the 2 down here. 2 times half here equals 1. And then I still have pi obviously here. And then this would just simply be pi times w here. So this here is the area prime, or the derivative of the area here is L plus pi w here. And what we can do is we're actually given our perimeter formula as well. Our perimeter formula, actually let me label this as number 1. And number 2 here is we have our perimeter formula, right? We know that P here equals the perimeter of the formula. The perimeter formula is simply is equal to 30 feet, but we know that perimeter is simply just the perimeter around the rectangle, right? So we can say it's one length here plus one width plus one width. This guy doesn't count, right? This length here doesn't count, and we care about this semicircle here, right? So we can say here it's simply just the 2 lengths plus a width here, because we only care about the 1 width. This here is inside the circle, so we're not going to count the perimeter of this guy here, and we care about basically half of the circumference of the circle. If a half of circumference, and we know the circumference of the circle here is pi or 2 pi r, right? 2 pi r. If we want half of the circumference for half of because this is circumference of a circle, we want circumference of a semicircle. So this is simply would be pi r, right? Okay, multiply by that half. So this here would be pi r here. And we know that r here equals w, right? So r, I can say that it's simply just pi times w here. And we know that perimeter here equals 33, right? So I have 2L plus w plus pi w. Right. So again, I have here a formula for basically my perimeter and my area. What I can do is I can isolate for one of these variables here, right? So maybe in this case here, I'm going to isolate for the second equation. I'm going to isolate for my length here. So I'm going to move pi w and w to the other side. So I'm going to have 30 minus w minus pi w equals 2L. I can say L here equals 30 minus w minus pi w all over 2, right? So this here is my length equation. What I'm going to do is I'm going to substitute this equation into L here to solve for, so I can solve for my w here. So I'm relating it to one equation here. So I'm going to get here, I'm going to do this in blue. So in this case, I would get a prime at t would equal the length, which is 30 minus w minus pi w here, all over 2, plus pi w here. And then what I can do is I can simplify this equation here. Let me just think about how I would simplify this equation here. So I can multiply. I can get rid of this 2 by multiplying basically this entire term by 2. And the area by 2 as well. So I can say that this is now 2 area here, prime, equals basically 30. I would have to do 30 minus w minus pi w plus, and then 2 pi w, right? Because I have to multiply this side here by 2, right? Plus 2 pi w. And then I can simplify 30 minus w here. So I have minus pi w plus 2 pi w here. So this would be, you can think of this as imaginary 1 here. So this would be simply just positive pi w, right? W here. And then all over 2, right? If I want to move back the a prime back to this side here. So this here would be another formula. What I can do is I can set my area here to 0. Right? If I set it to 0 here, I can solve for my maximum, for my critical point here. So if I set a prime here to 0, I can solve for my width here. So if I set this problem to 0, because if I set it to 0 here, I'm solving for my critical points, which is both the maximum and the minimum point because it's telling us to maximize our area here, right? So if I set it to 0 here, I'm going to get 30 minus w plus pi w here all over 2. I can simply just put 0 here, 30 minus w plus pi w here. I'm going to bring 30 to the other side. I can get negative 30 equals w plus pi w. In this case, I would get I can add both of these guys here, right? So I'm negative 30 here. It's going to equal basically 2w pi, or 2 pi w, right? 2 pi w here. And then I can divide that. I divide both sides by 2 pi to get my w here. So w here is equal to negative 30 divided by 2 pi here, which would equal basically some number. So negative 30 divided by 2 times pi would give me negative 15 pi, which is negative 47.12. Negative 47.12. And I, of course, width here can't be negative, right? Width here can never be negative. So it means that in this case here, width has to be positive here. So 47.12 would be my width. And then what I could do is I can substitute this guy for my length here. Yeah, I can substitute here for my length here. So to solve for my length, so if this is 47.12, my length here would be, let me just solve this guy here. So length here would be L equals 30 minus negative 47.12 minus pi times negative 47.12 all over 2. And what I would get here, a very, very big fraction, I'll just use my calculator. So this would be plus 47.12, then plus pi times 47.12 minus pi times negative 47.12, and then divided by 2. This give me a length of 112.5 feet here, which I don't think that makes sense because my perimeter is only 30 degrees. So something 30 feet here. Something is up with this problem here. So let me just double back and see if we made some errors here. So I set up my equation here. I found the derivative in terms of. Let me see if I wrote the diagram correctly here. Let me just download this image. I just want to see if this is the correct image. Just give me a second here. This is the correct image here. So that makes sense here. So okay, so I guess here in the radius of a circle here is not this guy here. It is this guy here. So I actually took the diameter. So there's my fault here. That's why my numbers were so big. So in this case, this is the height. This is 2r, and this here is r here. So I actually messed up here, and I actually put, instead of the diameter, this here should have been. This here is not the width. This is actually the diameter here. So what I have to do is I would have to actually modify these numbers here. So instead of getting half r squared here, I would get basically. This here would be 1/4 pi 1/4 pi w squared here. Let me just double back here. Let me just think about this here. LW plus half pi w squared. This would not be correct here because the radius here is not this guy here, so it's not this here. The radius of the circle is from here to here, right? So this here is my r, which is half of my width here. So I can say this is half of my width squared here. So this here is a much better algebraic expression, which means unfortunately I did my derivative wrong here. So let me just erase these guys here. Let me take the derivative again. So I have AT at prime here equals LW. So I'm taking into respect to W here. I would have L plus, or let me simplify this before I take the derivative here. So this here would equal LW plus, I have half times half here, or let me see, I have half of w squared. Yeah, okay, that's good. So if half of pi here, I'm gonna expand these guys here. Half w times half is 1/4 w squared, right? So and then what I can do is I can do lw plus half. I can multiply in, so half times 1/4 is simply 1/8 of pi w squared here. This would be my new AT. I'm taking the derivative here. Let me just erase these guys here. Should have clicked the picture now. I kind of regret it, doing all this work for nothing. But a prime here equals, again, I'm taking the respect to w. I have L plus, I have 1/8 here pi. Or I have w here. I'm going to move this 2 downwards. So 2 times 1/8 here becomes 1/4 pi w here. And this is the derivative of my function here. I'm going to set it to 0, which equals L times 1/4 pi w. And this here would be my the maximization of my area here. I believe I would have done my perimeter wrong here as well, because 30 feet is the perimeter of the entire thing. I'm going to add 2L, 2 lengths, 1 width, which is good, and I'm adding 2 pi r, right? Or half of 2 pi r, which is basically just pi r here. So pi of the radius here. Pi times the radius, sorry. Or pi times the radius here. 30 here equals 2 length plus width plus pi, and we know that the radius now is actually half of w, right? So half of w here. So I can say that 2 length plus w plus half pi w here, and then then this here would equal, this here now equals 30. So let me whoops. Let me just erase these guys here. I have 2L plus half pi w here. And then I can simplify this by saying 2L plus, I have 2 w's here. So which I can say that I have half times 2 pi w here, which is simply just 2L plus 2. These two cancel out, so I have pi w. So, yes, I believe, or actually, hold up. I'm adding these guys here. I have pi plus 2 pi plus half pi w. Yes, so I would have half of pi, which is 0.5 times 3.14. Give me a second. It's 1.57 plus 1 here. So I would get, give me a second. I would get, you can think of this as 2.57 w here, or you could just leave it as is. It doesn't really matter here. Basically here I want to isolate for L, right? I don't really care about these guys here. So if I want to isolate for L here, I can simply move all the w's to the other side. So I have 30 minus w minus half pi w equals 2L. Finally, L here equals this monster of an equation here, right? L equals 30 minus w minus half pi w all over 2. And then now I can substitute this into the equation here. So let me erase this. So this would probably be a thinking question in terms of grade 12. So this here equals 0. This is length, which is 30 minus w minus half pi w all over 2 plus 1/4 pi w, right? I have 1/4 pi w. What I can do is I can multiply both sides by 2. So this here is still 0. I get 30 minus w minus half pi w. In this case, I can multiply this term here by 2, right? And this here would give, I would get half pi w here. These two guys cancel out. Pi w and half pi w cancel out. So 0 here equals 30 minus w. And then I would get negative 30 equals negative w, and w here equals 30 here. So in this case, my width would be 30, and my length here would be, I'm going to just type this into my calculator. 30 minus 30 minus half pi times 30 all over divided by 2 here, which I would get negative 15 over 2 pi would be my length here, which doesn't make sense because I actually get a negative number again here. Let me just look back to our equation here. And we're going over time now, so it's okay, but I'm kind of determined to finish this problem here. So I'm just thinking about how we could figure out this problem here. Again, I have 30 minus w squared here, which is good. And let's see here. The area of the semicircle is half of pi r squared, and r is half of width, which here, if I squared both of those terms, I would get 1/4 w squared. I multiply half by 1/4, and this would give me 1/8 pi w squared here. So I might have to actually come back and do this problem, just because we've run out of time here. So let me so I might have to come back and do this problem for you as well. But I guess we'll pick off this problem. We ran out of time. We will look at this problem again, actually, probably in the next video, and I think we'll redo this question just because I took way too much time looking at the radius of this problem here, and how it was different here. So I'll come back to this problem and we can verify the solution for next video. So sorry about that. Kind of a buzzkill here, but I'll redo the solution here so that we can look at the solution for next time here. So thank you so much for watching again. If you found this video intuitive, you can definitely follow the OneClass YouTube channel, and we'll be able to kind of get started on that, and we'll be able to kind of help you out in terms of math problems or chemistry problems though. As always, thank you so much for watching. Stay safe, stay healthy. Have a great day. Take care.